Hello, how are you doing? I hope you're doing well. Just, this is the second kind of video, just recording myself doing questions just to kind of help me review and just challenge myself into learning stuff more deeply. I'm not going to go into every single detail about these questions, just kind of want to like quickly go through them and just explain my thought process so that it makes more sense to me. But, if anyone else could benefit from it, that would be nice. So I'm currently a first year university student. I'm actually a tutor at Kumon. I'm not sure if you've heard of it. It's just the really kind of sad logo with the sad face in the middle. But yeah, I mainly just tutor math there, and I really enjoy the job. I enjoy math a lot, but I just kind of want to challenge myself with extending to different subject areas. I'm also planning on writing the DAT this year, so this could help me with kind of reviewing. So maybe later down the road, like when this semester is over, then it'll be more focused on different things like biology, stuff like that. But right now it's just chem, just the courses I'm in. So yeah, I'm currently getting molested in Chem 261, my organic chem class. And I feel like I would just butcher anything I'm trying to teach. But yeah, so that's like kind of a quick intro. I don't know if I'll do that every single video, but yeah, anyways, so sodium benzoate, this is just Na plus, and then we got C6H5COO minus. What we're trying to find here is the pH. This is what the question mark is. And the information that we're given is the molarity of this solution, of this basic solution, because as you can see, it's just a base, bro. So if we have a base here, we're trying to find the pH. How would we do that? We need to find the pOH. Because if you can find the concentration of the base in solution, we could just find the pOH and then subtract that from 14, and then we would get our pH. So that's kind of what we're trying to do. We're just trying to find the concentration of hydroxide ions in the equilibrium solution. So that's kind of what we're going to do. The first thing I would like to do, or that will make it easier, is to draw the ice table. Or first, we want to draw the reaction. So C6H5COO minus plus H2O equilibrium. Oh, I should probably put my states in, but it's not really that deep. C6H5COOH plus OH minus. So this is what we're looking for. This is the question mark, the concentration. So now making an ice table real quick. Ice. So it's just initial, change, and equilibrium. I remember, bro, I used to think this was eventual, and I actually got docked marks on my lab, which is kind of tragic for writing eventual, but I guess we learn. That's how we learn. So it's just annoying. So now we'll start with filling this in. We got the units, which is molarity, or moles per liter. We start with 0.25 moles of solution. I don't know why I wrote that twice. We don't have to worry about the water in this, and we start with 0 products. So with 0 products, that means the reaction is going forward. So what it means that the reaction is going forward, that just means the changing concentration for reactants will be negative. So we have negative X, and then the changing concentration for the products will be positive. So we got positive X, positive X. So this would be X, X, and 0.25 minus X. So now we could write this equilibrium constant equation, or whatever you call it, where products are on the top, and then reactants are on the bottom. So this would just be x squared over 0.25 minus x. So now if you remember from the previous video, we have to set this to the equilibrium constant, but we don't have that. So how do we find that? We just have to find that, bro. So for me, what I have provided is I have the Ka values of these acids. So if we find the Ka of C6H5 COOH, for me, what the value is 6.31 times 10 to the negative 5. That's just the Ka value of C6H5COOH. That's just this right here. So now, I'm not sure if you know this, but Kw is equal to Ka times Kb. It has something to do with water, stuff like that. I don't really know that much deeply about it, so I'm not really concerned about that. All I'm really concerned about is just how we find the Kb value. So Kb is equal to Kw over Ka, and Kw is equal to 10 to the power of negative 14, and then we just divide that by the Ka value we got provided from our formula sheet or data sheet. Once we do that, we will get a value of But I gotta enter this in my calculator. 1.58 times 10 to the negative 10. So this is our Kb value, and we could input this into our equilibrium concentration formula, equation, or whatever we call it. Also, one more thing, I'm not sure if you recall from the other video, is that we have a small case scenario here, because this is much smaller than 10 to the negative 3. So therefore, we could make the assumption that that the change in x is kind of negligible, because if you have a small k is proportional to products over reactants. And if the reaction, or K, is occurring at like a very small amount, that means the change will be like negligible. That means like we don't have to like account for the change in X. So with that, we could assume that 0.25 minus X is just basically 0.25. Because we don't have to assume the change in X. So that makes it much more easy, because we don't have to distribute the 1.5 times 10 to the negative 10 to both terms, and we can just solve it for what it is. So with that, we would get x squared over 0.25 is equal to 1.58 times 10 to the negative 10. Now if we just solve that, we should be able to get x is equal to 6.29 times 10 to the negative 6 moles. I don't really want to walk through all the calculations I put in my calculator, and it's just pretty simple algebra. So this is what we get for x. So we're not done the question yet, because the question remains, what is the pH? And like I said before I started, we want to find the pOH. And in order to find the pOH, we need the concentration of OH minus, or hydroxide ions. And if you see from the ICE table, the concentration of hydroxide ions is just X. And that's what we calculated here. So we could just write the OH concentration is equal to 6.29 times 10 to the negative 6 molar. And now, I'm not sure if you know this, but pOH is just equal to the negative log of the concentration of OH minus. And once you input this into your calculator, you would get 5.20. So the pOH is 5.20, but we need to find the pH. pH plus pOH is equal to 14. Therefore, pH is just equal to 14 minus pOH. This is 14 minus 5.20, and you should get a value of 8.80. And this is equal to our pH, and that is the answer to our question. So ideally it made sense. All we have to do is just establish the ICE table, find out what the Kb value is from the Ka value, then just solve for x, small k question. Also, one more thing, you want to do the 5% assumption thing, but it's kind of tedious, so I don't really want to do it. But yeah, that's basically how you do this question, pretty simple. The next question will be a bit more complicated. Okay, so this is the next question. Honestly, I don't know how organic computer be recording these videos, right? I low-key need to take a break in between. But anyways, this is the next question. It's not in chronological order, but this question is a bit more complicated than the other one. So I guess we'll start it. We're basically doing the same thing, but this time this is different. So I'll kind of just explain why. The first thing I would probably do is just write out the equation. So CHCl2COOH plus H2O. But this is so tedious. COO minus aqueous plus H3O, because this is an acid. So we want to make the ICE table initial change equilibrium. And yeah, so we could start with 1.00 moles here. Minus X, because the reaction is going towards the right, because we start with 0 moles of product, plus X, and we don't really have to concern ourselves with H2O. So with trying to find the pH, we want to find the concentration of H3O, and this is kind of what we're looking for. This is the main thing that we want to find, and then we have the answer to our question. So we start with 1.00 minus x, and then x, and then x. Now, the main issue with this one is if we get the Ka value for this, we find that it is 4.5 times 10 to the negative 2, I believe. Yep. So this means that this is an intermediate K question. I didn't go through any of these on the first video, so I guess this is a nice segue into doing it, but mainly we just have to use the quadratic formula to find this out, which is quite annoying. Okay, so let's start with this. So once we write out this kind of equilibrium equation or whatever, we got the products on the top, which is just x squared, and 1.00 minus x. So now because this is intermediate, we can't make the assumption and just assume that 1.00 minus x is just equal to 1. So we have to deal with the expansion. But I don't know if the microphone's picking up like every time I swallow. Pause. But once we just distribute the denominator to both sides, this is what we should end up with. So we could just move everything to one side. But this is a bit tedious and frustrating. So I'm not sure if you know what the quadratic formula is, but I mean, I did Kumon, so I kind of memorized it. But negative b plus or minus square root of b squared minus 4ac over 2a. So we just got to substitute this in. So I guess we could just put a 1 here for convenience. This is our a value, this is our b value, and this is our c value. So now we just got to input these into the formula. This is what I mean by I don't really like the intermediate K questions. It's just really annoying. But I gotta book my econ exam. I forgot to do that. I'm gonna do that right after this video. I was supposed to do it last week, and but I'm cooked for that. Anyways, so we find x, and I guess we could solve for it. It's just it's just really annoying tension in my calculator. But what you should get is one value of x being 0.191, and then another value of being negative 0.236. So clearly we can't have a concentration that is negative, so that means this question is extraneous. I mean, this solution is extraneous, so we can't really count this as an answer. So that means this is our answer for what x is going to be equal to. So now if we look back up here, we know that the H3O concentration is just equal to x. So that means H3O equals 0.191. And we can find pH from this. pH is equal to negative log concentration of H3O, so 0.191. And that should be equal to 0.719. And this would be our answer. So yeah, really simple. Not really simple, but pretty straightforward, I would say. Just solving for x basically. The main issue for me, honestly, is just establishing this first portion here. This is what I struggle with the most. So kind of helps that I'm like writing it out and thinking it out and speaking it out so that I fully understand what I'm looking for. But yeah, that's honestly basically it. Honestly, I want to try and get a video every single day, so I kind of force myself to study as well by doing this, but we'll have to see. So yeah, that's pretty much it for today. Hope you enjoyed, and I'll see you tomorrow.